So today is our fourth class, right? Everyone for the OSPF. And guys, today class we are going to discuss first thing about the router ID. What is router ID? Fine. Do you guys see router ID? First of all, let's suppose I can show you one thing. Come here on this router. I am opening this router. I will show IP protocol. See, OSPF 300 is configured here. Yes or no? Yes, everyone. Are you tell me? OSPF 300 is configured on this router.
Yes.
See here one thing. Router ID. What is this? Router ID. Show IP OSPF database. I write this command. So IP OSPF database. What do you mean by this? Anyone? What is the use of this command? I told you, na, every router maintain the one LSDB. In yesterday class, I told you. Tell me yes or no. In yesterday class,
Yes, sir. Yeah,
LSDB.
right.
Yes. I told you, na, this one. Yes or no? Yes. So every router in OSPF maintain one LSDB. It means database table. Okay. And in this database table, router install the all database there. And that is called LSDB. What is this, guys? This is LSDB. And in this LSDB, this router install this prefix information as well as this prefix information. Getting my point? Everyone tell me. Now, why I am showing this one? When I write this command, please read this line, guys. OSPF router with ID 20.0.0.2 and process ID is 300. It means on this router, you are running router OSPF 300. It means that is the process ID. Yes or no? Yes. So that's the reason process ID is visible here. Fine. Now, the very, very important. What is this? This is
IP format.
This is router ID. What is? This is router ID, guys. This is what? Router ID. Now, what is the conclusion here? So please remember one line. OSPF mention its LSDB with the name of router ID. Or you can say OSPF LSDB is represented by router ID. Getting my point, everyone? Yes or no? Understand? So, for example, this is R1. Am I audible to all of you? Everyone?
Yes. Yes.
Yes, it will buffer. Basically, power goes down. So router is applying. Just wait. Meanwhile, what we are discussing, I don't know. It's
router ID.
Is my screen visible?
No.
No?
No.
Okay. So see, for example, we have a R1, we have a R2, we have a R3, there is a switch, and through this switch, all the routers are connected like this. Fine. So if R1 is sending its database, R2 is sending its database, and R3 is sending the database. Getting my point? For example, R2 receive first its own database, R2 receive R1 database, as well as R2 receive R3 database. Yes or no? Everyone, tell me. Yes, it means every router have how many database? 3 database. How many database? 3 database. Right? Now the point is how every router will identify this database belongs to R1, this database belongs to R2 or R3. The answer is with the help of router. So please remember router ID. Router ID, it's database over the network. My point, everyone. So when you check the router ID, according to the router ID, you can easily identify this database belongs to which router. Getting my point, everyone? I hope you guys understand. Understand?
Yes.
Now the point is actually how router ID is elect. How router ID is elect. Fine. See, each OSPF router has a unique router ID. Please remember. For example, in a network, you have a 3 router. Please remember, on every router, there will be a router ID. Fine. And that router ID must be unique. That router ID must be unique. Getting my point? For example, this is the R1 and this is the R2. On R1, the router ID is 1.1.1.1. And on R2, you configure the same router ID 1.1.1.1. What will happen? Neighborship will not form. Neighborship will not form. So that is the also neighborship criteria. Whenever you want to establish the neighborship between R1 and R2, your router ID must be unique. Understand? Everyone, tell me.
Yes.
Yes.
So please remember, in case of OSPF, every router has unique router ID. Fine. Which is like the ID card of the router. The router ID is, what is the size? Please remember 32-bit. Size of router ID is 32-bit. This router ID must be unique across the OSPF network. I told you. Right now, for example, there are multiple routers, 5, 2, 5, 6, 7, 10 routers. For every router ID will be unique. Then all the router will identify that database belongs to which router. Getting my point, everyone? Yes or no? Yes, no?
Yes.
If
Yes.
two router have the same router ID, they won't be able to establish the neighborship. Fine, everyone? Clear now? Now, the next thing is actually how router ID will on a router, how router ID will elect. Fine. The first method is manually configured. You can configure the router ID manually. Again, I am telling you can configure the router ID manually. Getting my point, everyone? Second thing, if you do not configure the manually, then second criteria for router ID is highest loopback address. What is highest loopback address? Let's suppose if you do not configure the loopback, then highest interface IP address will become the router ID. Fine. Now see what I'm trying to say. R1, R2. Here I configure 10.1 Here I configure 10.2. Fine. There are two more interface. IP address is 20.1. IP address is 50.1. On this router, on every interface, what is running? OSPF is running. Okay, everyone. On router number 1, I configured some loopbacks. Some loopbacks. On R1, I configured 1.1.1.1, 2.2.2.2, dot 5. Done, everyone. Anyone have any question? Tell me.
No, sir.
No? Understand? Now see. When you configure the OSPF on R1, how R1 will choose the router ID? Fine. What is the first thing? Either you can configure the router ID manually. The first criteria is, guys, what is the election criteria? The first is manually. You can configure the router ID manually. Okay, leave it. How we can configure the router ID manually, I will tell you later. Now, second thing, let's suppose I do not configure the router ID manually. Then what will happen? Router OSPF choose and tell me what? Highest
IP. Loopback. Sorry.
Address. So tell me on R1, how many loopback you guys configured? 1, 2, 3. Which is highest? 5.5.5.5. This is highest. Yes or no? Yes. So in this case, for R1, what will be the router ID? 5.5.5. Understand everyone? Tell me yes or no.
Yes.
Yes.
For example, I do not configure the loopback here. For example, I'm audible now, everyone? Yes or no?
Yes, I'm getting you.
Is my screen visible?
No.
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 Wait. Now it's visible?
Yes.
Yes.
Okay.
Yes.
So what I'm telling, for example, I do not configure the loopback here. What I'm telling, I do not configure the loopback. Then what will happen? See, on this router, I do not configure manually. Loopback is also not there. The third thing router check, that is interface IP address. Yes or no? Everyone, tell me.
Yes.
Yes?
Yes.
Yes, that's the highest, the
If you
highest
do not
IP
configure
address.
these two, then router will check the interface IP address. Now on R1, how many IP address you configured? 10.1, 50.1 and 20.1. Now tell
50.1.
me, which IP address is the highest? That is
50.1.
50.1. So it will become the router ID. Getting my point? Everyone, tell me yes or no. Understand? So this is the election criteria for okay. So this is the election criteria for router ID. I hope everyone understand. Tell me yes or no.
Yes.
Yes.
Yes, sir.
For example, come here on R5. On this router. When we are on this router, enable First of all, I am checking OSPF is what is configured here. So IP interface brief. See, only what is configured here? Only 20.2 is configured here. IP address is configured here. Yes or no? Everyone, tell me. Yes? Tell me. So IP protocol, I am checking OSPF is configured. And what is the router ID? 20.2. Tell me yes, na? Because on this router, you do not configure the router ID manually. First criteria, fail. Second thing, you do not configure any loopback. So second criteria is also fail. Now come on the third one. On this router, how many interface you configured? Only this one, gig 0/0. Yes or no? Tell me, right? Na? On gig
Yes.
0/0 you configured. So that's the reason. The IP address which you configured on gig 0/0, that is 20.2, and that IP will become the ID. Understand?
Hello,
Everyone.
hello. Can you come again? You said something now that because we only configured gigi by 0/0, so that means we cannot. Why not that 50.0? Is it because it's not configured on gigi by 0/0?
Yes, on gig 0/0/1, you do not configure any IP address. For example, see, interface gig 0/1. Okay,
Mhm.
IP address 50.0.0.1 255.0.0.0, and I'm writing no shutdown exit. Okay, router OSPF 300. We are running here 300, right now, everyone? Yes or no?
Yes.
We are running here router OSPF 300. Okay, so
Mhm.
we need to advertise 50.1 also in the OSPF. Okay, now then after any prefix will part in the election of router ID. If you do not advertise that network in the OSPF, then that interface will not be part of router ID. Okay, na? So what I am doing, I am configuring IP. Sorry, what is guys? Network 50.0.0.1. What is the wildcard mask? Tell me.
That's
0.255,
0.255, 255, 255.
area is 0. So I advertise 50 dot also. Show IP protocol. See, 20 network is also advertised and 50 network is also advertised. But right now, what is the router ID?
20.
20.2. Now you guys will ask, sir, you told highest interface IP address will become the router ID, but still 20.2 is there. But what is the highest here? 50.1,
0.
na? Everyone, yes or no?
Yes.
Yes. But why this one not? This is not the router ID. Anyone? Tell me, guys. No?
No.
I am running one command. Clear IP OSPF process. Yes. Show IP protocol. That is the problem in the packet ratio. Clear IP OSPF process. Yes. Show IP protocol. Clear IP OSPF process. Yes. Show IP protocol. That is the problem in the OSPF actually. But please remember one thing. When you change the router ID, again I am telling, when you change the router ID. After that, you have to write one command here, IP OSPF process. It means when you write the clear IP OSPF process, what you are doing? You are just clearing the OSPF, or you can say you are just resetting the OSPF process. And when you reset, what will happen? Tell me what will happen? Again, election will happen. What will happen? Again, election will happen. Getting my point? Tell me.
Yes.
Everyone, understand?
Yes.
But it should work here, but I don't know why it is not working in the packet, Risha. Let me check here. On R1, show IP protocol. No, nothing is configured. Router OSPF 100 network. What is this? 40.1, right? Na 40.0.0.1. What will be the wildcard mask, guys? 0.255, 255, 255. Area is 0. Yes, na everyone? Yes or no? I am going to advertise one more network. Network 1.1.1.1. And what will be the wildcard mask?
0.
255.
0. Area will be 0. Are you done na everyone? Yes or no? Yes.
Yes.
I am going to one more advertise. That is the interface. Which one? Let's suppose 10.0.0.10. Wildcard mask will be 0.255, 255, 255. Area is 0. Anna, I am writing to show IP protocol. See, OSPF 100 is running here, and how many network we advertise? 40 network we advertise, 1 network we advertise, and 10th network we advertise. Yes or no? Yes, no?
Yes.
Everyone. Now, tell me in this case, which one will become the router ID? First,
No.
manual thing. Manual I do not configure. Then, router check the loop back. On R1, which loop back you configured? 1.1.1.1. Yes, na? Everyone. Tell me.
Yes.
So that's the reason. What is the router ID? 1.1.1.1. Getting my point, everyone? Yes or no?
Yeah.
Yes.
Tell me. Yes, na? Okay. For example, interface loopback 1. Shut down. I just shut down in and am writing to clear IP OSPF process. Yes. To show IP protocol. That is the problem in packet restriction. But when you disable the router ID, what will be the router ID here? Tell me. Highest interface IP address, that is either 40.1 or 10.10. Which one?
40.
40.1. So that should become the router ID. Getting my point, everyone? Yes or no?
Yes.
So that is all about. And one more thing, let's suppose if anyone asks you how can you configure the router ID, what is the command? Anyone? What is the command to configure the router ID manually? See.
OSPF.
Yes.
Process
Router,
ID.
process ID, and then go router ID. That is the command. Getting my point, everyone? See. On R1, router OSPF 100 we are running here. Yes or no? Yes.
Yes.
Then write router ID. For example, here I am want to write 4.4.4.4. One more thing. See what is happening. What when I press, you are getting na clear IP OSPF process. It means this is telling you need to write this command if you want to implement this. Are you getting my point? So I am writing to clear IP OSPF process. Yes. To show IP protocol. See, now change. Now change. Getting my point, everyone? Yes or no? Understand? So basically, this is the way how you can change the router ID. Now, do you guys see one thing? I don't know you guys observe or not. Tell me one thing. What is the router ID I change here on this router? 4.4.4.4. Right? Yes or no? Yes.
Yep.
Tell me one thing. Show IP interface brief. Is this IP address configured?
No.
No. This IP address is not configured here. But still I am able to change router ID. That is not configured. So please remember, in OSPF that is possible. In OSPF that is possible. Getting my point? The IP address, no matter IP address is configured or not, you can change the router ID. Getting my point, everyone? Understand?
Yes.
So that is the feature in the OSPF. But in case of BGP, you can't. Then everyone, understand?
Yes.
Anyone who do not understand router ID? Clear na? When you write so IP OSPF database, still nothing is there. Why? We will discuss these things later. But now when you check the database table, your database will be represented by 4.4.4.4. Right now, everyone, tell me. Understand? I told you now what is the use of router ID to represent your database. Represent your database. I'm audible, guys.
Yes, sir.
Okay. So I hope now you guys understand the router ID. Yes?
Yes.
Okay. OSPF process ID we already discussed, right? Everyone.
Yes.
Router ID and process ID. I hope you guys understand the difference between process ID and router ID, right now? So by the help
Yes.
of process ID, what we are doing? We are just separating the local configuration, right now? And what is the use of router ID? By the help of router ID, we just represent our database, right now in OSPF, in complete network,
Yes.
right? Everyone. Now, I already told you about the concept of area in the OSPF, right? Basically, in case of OSPF, all the router will be the part of same AS, right now?
Same thing,
Everyone. So to avoid the load on each and every router, we have a concept of area, right now? So by the help of area, what we are doing? We are just dividing the network logically. Tell me yes or no. Yes, na? That is
Yes.
area. Fine. And I already explained you there are multiple types of area: backbone area and non-backbone area. Area 0 is known as backbone. And other than
Backbone.
area 0, for example, area 1, area 2, area 3, that are called
None.
non-backbone. Getting my point? On the basis of area, there are how many types of router? I already told you. First one is backbone router. Backbone router means all the interface present in the area 0, that is called backbone router. Non-backbone router means, tell me guys,
Other area.
one interface will be in the another area. Now, next one is ABR router. ABR router means one interface will be in the area 0, another interface will be different area. That means ABR. ASBR. One interface will be in the OSPF, another interface will be the different routing protocol. Then that router is called ASBR. So I already explained you these things, right? Now everyone, yes or no?
Yes, sir.
Now, OSPF maintain total 3 types of table. I'm not going to tell you the routing table because I hope everyone already know about the routing table. Yes or no? Right now, router already maintain routing table.
Routing
Neighbor
table.
table. Neighbor table means Basically, OSPF maintain one table that is called neighbor table, and in this neighbor table, router store the information about its neighbor. Which one? Its neighbor. Getting my point, everyone? Yes or no? What is the command to check? Who can tell me? What is the command to check? Anyone?
Show IP OSPF neighbor.
Yes. For example, here I am writing so IP OSPF neighbor. I am getting the result. Yes or no? Everyone, tell me. Yes.
Yes.
So this is the command by which you can check what? Table. Neighbor table. So Ccna, what is this? Neighbor ID. Neighbor ID is 20.0.0.1. What is this? Neighbor ID is 20.0.0.1. There is another use of router ID. What is this? This is the router ID. Not do not confuse with the interface IP address. No. There are two use of router ID. First one, by the help of router ID, you can represent the LSDB, right? Na database. And second thing, in OSPF, every router is represented by router ID. Again, I am telling, in OSPF, every router is represented by router ID. For example, let's suppose on this router ID is 1.1.1. This router 2.2.2. This one is 3.3.3. Fine. So it means every router here, every router in the OSPF. Fine. Find or identify any router with the name of router ID. For example, how I identify Nabil? By the help of his name. They're getting my point? Yes or no?
Yes.
In the same
Yes,
way,
sir.
in OSPF, every router is represented by router ID. Getting my point? This router number 1, don't know router 3. Let's suppose you configure the IP address 50.2, or either you configure the, let's suppose I change the host name. The host name is Baba. So this router don't know who is Baba and what is 50.2. No, this router always identify this router by the name of 3.3.3.3, that is router ID. Getting my point? I hope this is clear to all of you. Done, na? So that's the reason when I write the show IP OSPF neighbor, this router know its neighbor by the name of router ID only. Done, na? This is priority. Priority is by default 1. And what is state? What is, guys? State. State is what? Full and BDR. What do you mean by full? Full means, let's suppose if there are two router, and when you configure the OSPF on the two router, first of all, both router exchange the hello packet. Yes or no? Yes. When both router exchange the hello packet, in hello packet, what is happening? I told you in yesterday class, neighborship parameter exchange. Yes or no? Yes. When both router exchange the neighborship, fine, all the parameter will match. Then both router will become neighbor. Both router will become neighbor. And once both router will become neighbor, what will happen? Both routers start exchanging the database. Yes or no? Yes. So full means what? Full is the name of state. Full is the name of state. When two router become the neighbor, then state of both router is full. It means you can say router always share the database in which state? Full state. Are you getting my point? Everyone understand?
Yes.
Shubham,
Yes.
please, what is it now the difference between with adjacency and no adjacency?
See,
OSPF.
adjacency means what? When both router exchange the hello packet, every neighborship parameter will match. After that, both router exchange some more packets. When everything is done, okay, then router will move in which state? Full state. Okay, and that full state is known as adjacency. It means now router is in adjacency state or adjacent. Adjacent means now router is ready to exchange everything. Now router is ready to exchange everything. Getting my point? So after full, that is adjacent. Done.
Thanks.
That is the address. Address means that is the interface IP address of your neighbor. Okay. And that your neighbor is connected on which interface? This one. So that is called, guys, which table? Neighbor table. Okay. And the third one is database table. What is the command to check the database? So IP OSPF database. So this is called which table, guys? Database table. And this database is represented by router ID. Yes or no? Everyone tell me. Yes, na? So I told you how many things? There are 3 type of table OSPF maintain. First one is neighbor table. Second one is database table. And third one is routing table. So IP route. This is called routing table. And I told you in the yesterday class, whatever the best route which is present in the database table, router install that route where? In the routing table. Done now, everyone? Yes or no?
Yes, sir.
Yes.
Yes.
So router maintain total 3 types of table. This one we already discussed. Types of area, backbone area, non-backbone area. Right now, everyone? Yes or no? Communication rule I already told you, right? Non-backbone area cannot communicate directly with each other. Right now, they must pass through the area 0. Right now, everyone? Tell me. Yes. Types of OSPF router. Backbone router I told you. Non-backbone router I already told you. ABR router I already told you. ASBR router I already told you. Right? Everyone?
Yes.
Okay. Communication between different protocols. If you want to communicate, let's suppose this is the router 1 and here you are using the OSPF. Fine. And here let's suppose different routing protocol. How can you make communication possible in the different routing protocol? The process is known as redistribution. What is redistribution? Okay. And please remember one more thing. This is very important. If any interviewer will ask you, or let's suppose you get the question like this: redistribution we configure on which router? First option, backbone router. Second one, ABR router. Third one, ASBR router. Fourth one, all of these. Which one?
HBR.
Exactly. ASBR router. Understand, everyone?
Yeah,
So please
the reason
remember,
is because it involves
yes, it
OSPF
involves
and
different
another routing protocol.
Yes, that's the reason.
It makes more
Under-
sense.
Sorry?
It makes more sense.
Yes. Because ABR router means what? That one interface will be the different area and another interface will be in the different area. But in the same protocol, na? Yes or no? Yes. But ASBR means one interface will be in the OSPF, another will be different routing protocol. So it means you need to perform the redistribution on ASBR only.
Yeah.
Understand, everyone? Tell me yes or no.
Yes, sir.
Okay. Types of messages in OSPF. So these are the types of messages OSPF exchange. So you guys need to remember this one. Which one? Hello, R1 and R2. First R1 exchange the which packet, guys? Hello. One hello will exchange then DVD, that is called database description. Okay. Database description means that router will share the, or you can say, overview of its database with each other. That is one. LSR, request, LSU, update. LSU request means, for example, this router share the database. Okay. And in this database, this router is telling something about the 2.2.2.2. But this router don't know the exact information about 2.2.2. This router only receive the overview from this router with the help of which message? DVD. DVD. So what will happen? This router generate again which message? LSR. LSR means request. So this router share is generate the request, and in this request message, this router is telling, please tell me the detailed information about 2.2.2.2. Again, this router share which one? LSU. It means in this packet, in this message, this router share the complete information about 2.2.2.2. Getting my point? So that is the meaning of LSR and LSU. And what do you mean by LSAC? Once this LSU packet R1 receive, then R1 will send what? LSAC. It means R1 is sending the acknowledgement to R2. Yes, I receive your message. Are you getting my point? Yes or no? Tell me.
Yes.
So that is the meaning of LSU, LSR. Done na everyone? Anyone who do not understand? Anyone? It's clear?
Yes.
So if any interviewer will ask you, tell me in OSPF how many types of messages? How many types of messages? First one is hello. Second one is
DBD.
first one is guys hello. Second one is DBD. Third one is LSU. Fourth one is LSR. And fifth one is LSAC. This is R1. This is R2. On R1 and R2, you configure the OSPF. For example, on R1 database have 1.1.1, 2.2.2.2, 3.3.3.3. This one is connected. Let's suppose loop back. This is loop back. This is also loop back. Here you configure. Let's suppose 50.0.0.1 that is connected on 0 by 0. Let's suppose there are one more 60.1.0.0.1 that is connected on 0 by 1, and here you configure 10.1 and 10.2. So tell me one thing. This is the database of R1, yes or no? Everyone agree?
Yes. Yes.
Yes.
Agree? You configure the OSPF. It share the hello. It share the hello. What will happen? In hello, both router. Yes or no? Both after hello, both router will become neighbor. Yes or no? Yes. After that, both routers share what? DBD. Both routers share which message? DBD. In this DBD message, both router only sharing the 1.1.1.1, 2.2.2.2, 3.3.3. The only this one, not complete information. Getting my point? So this router share and this router share. So let's suppose when this router receive this one, so this router now understand. See, actually, I know only 10.1 for about this router. Right now, router number 2 only know about the 10.1, because this router only connected with this link. Yes or no? Yes.
Yes.
This router do not have complete information about this database. Yes or no? Yes.
Yes.
This router only receive the overview of all the database which is present on R1. Fine. With the help of which message? DBD. Fine. What this router will do? This router generate the LSR. In LSR, this router is telling 1.1.1.1, 2.2.2.2, 3.3.3.3, 50.1, 60.1. So in LSR, this router share these prefixes. It means what? By the help of LSR, this router is telling to this router, ki bro, I receive your DVD, and in the DVD you are telling something about 1, 2, 3, 50 and 60 network, but still I don't have full information about your network. So please share me the complete network information. Getting my point? And this router is telling these things by the help of which message? LSR.
Yes. Yes.
When this LSR will receive on R1, what R1 will do? R1 generate LSU. In LSU, R1 will share, see 1.1.1, that is my loop back. 2.2.2, that is my loop back. 3.3 is my loop back. 50.1 is connected on my 0 by 0. 60.1 is connected on 0 by 1. Fine. And this interface is connected directly, statically, manually. There are multiple information. Okay, na? So this router share these information with R2 with the help of which message? LSU.
Yes.
Fine. So when LSU will receive on R2, what R2 will do? R2 install all the prefixes information which are to receive from R1 in which table? LSDB. Which table, guys? LSDB. Are you getting my point, everyone? Yes or no? Yes. In which table? LSDB. Now, what this router will do? This router run the SPF algorithm where? In LSDB. Which algorithm? SPF
Yeah.
algorithm.
Oh, God.
And once SPF algorithm will run, this router find the best path for every network. Yes or no? Yes. And install that path where? In the routing table. Where, guys? In the routing table. And once this router receive the LSU from R1, this router send which one? LSAC. LSAC means this router is telling to R1, thank you, bro, I received your message successfully.
That's
So that is the,
acknowledgements.
yes, that is the acknowledgement. I hope now you guys understand how actually the thing is happening. Understand,
Yes.
everyone?
So all the existing path in SDB routing table will not take, only the best path it will take.
Yes,
From
only
there?
the best path you will see in the routing table. Only best. So that's the reason this SPF algorithm always run where? In LSDB. Understand, everyone? So basically that is a use. I written here some point about the hello packet. Okay, so just read these point. This message is used to establish the OSPF neighborship. I hope everyone know, right? This act like a keep alive message. In yesterday class, I told you OSPF message works like a keep alive message also, right? Now everyone, okay.
Yes.
Router exchange the hello message after every how much time? 10 seconds.
10 seconds.
Fine. What is the dead time for hello message?
40
40
seconds.
seconds. It means if any router do not receive the hello message till 40 seconds, then this router will announce my neighbor is dead. If neighbor router does not receive a hello packet within the 40 seconds, it assume your neighbor is down. Done na everyone? Yes or no? Yes.
Yes.
In hello message, router exchange the neighborship parameter I told you. Right na? When both router
Yes.
agree on that parameter, then both router will become neighbor. Are you understand everyone? Yes or no? Yes.
Yes.
Now, this is also very important question. What are the neighborship parameter? What are the neighborship parameter? For example, this is the R1, this is the R2. On both router, you configure the OSPF. On both router, you configure the OSPF. Now interviewer will ask you, tell me, at which condition both router will become the neighbor? Getting my point? What are the condition? So please remember these things. Each router must have a unique router ID. I already told you. Yes or no? Everyone. Yes? Let's suppose on this router, if you configure 1.1.1.1 and if you configure 1.1.1.1, both router will become neighbor. Answer is
No.
no. Router ID must be unique. If you configure here 1.1.1, here must be a 2.2.2.2. Are you getting my point, everyone? Yes or no? Yes, na? Now, second condition is router must be in the same area. If one router will be in the area 0 and another router will be the area 1, this is not possible to become the neighbor. Are you getting my point? Yes or no? Third thing, router must be in the same subnet. Same subnet means same network. For example, here you run 10.1 and here you configure 20.1. Both router will never become neighbor. Are you getting my point? Yes or no? Yes, na?
Yes.
So if you want to become the neighborship, both routers should be in the same subnet. For example, here R1, here R2, here is IP address 10.1, here is 10.2. For example, you configure here one loopback 1.1.1. So tell me one thing, between this loopback and between this IP, this router, neighborship is possible? Answer is no. Why? On this router, what is the IP address you configured here, guys? 10.2 and here 1.1.1.1. Both are in the same subnet or different subnet? Different subnet. So neighborship is not possible. Getting my point? Everyone, tell me. Understand? The fourth one is hello time and dead time must be match. Hello time and dead time must be match. For example, this is the R1. R2 by default hello time is 10 and dead time is 40. And tell me yes or no? Yes, but you can change it. You can change it, but generally in real scenario we are not changing, but you can change it. Okay, but if you are changing, make sure on this router and on this router, both hello time and dead time must be match. Are you understand? Everyone, tell me yes or no.
Yes.
Yes.
Anyone who don't understand? Are you tell me, guys? Understand na? All the parameter.
Yes.
Yes.
Yes, we can change the hello time and dead time. Okay. There are command. I don't know in OSPF. Sorry, in packet tracer it will work or not, but I can show you. Let me. For example, here. Show IP protocol. Yes, OSPF is running here. Conf T interface gig 0/1. Okay. Command is IP OSPF. Let's suppose I'm writing hello interval and press the question mark. See, so you can change this time. Are you understand? Yes or no? Everyone. Understand
Yes.
now? Yes. Same way, IP OSPF dead interval. So you can change the dead time. Understand, everyone? You can change the hello time and dead time, but generally in real scenarios also we are not changing this type of thing. But if you are changing, must be match. Authentication is enabled, must be match. For example, of in any router, if you configure any types of password, then authentication must be match. Stuff flag must be match. That is the advanced thing, but please remember this. I just written this because interviewer can ask you stub. Basically in OSPF, in CCNP, you guys will learn we are making stub area. Okay, in stub area there are multiple LSA or LSDBs filtered out because we do not want on a router heavy load. Okay, now to reduce the heavy load, we are making the stub area. Fine. So when you enable the stub area, router start exchanging the stub packet. Okay. So when stub flag must be match. Otherwise, both router will never become the neighbor. Ccna by default stub bit is off on all the router. When you configure the router to be the stub area, the router will start sending the hello packet. And in this hello packet, what will happen? Stub bit set is on. Stub bit is on. Are you getting my point? Yes or no? Yes.
Yes.
By default it is off. But when you enable it, router start sending hello packet with enable the stub bit. Fine. If the neighbor router is not configured the stub area, it means that on that router stub flag is on or off? Off. Right now. But your router is sending stub flag on na? Yes or no? It means this is mismatch and neversible down. Are you getting my point? Yes or no?
Yes.
Understand? So this is the way router OSPF1 area 1 step. This is the command by which you can configure the stub area. But this is the advanced thing in CCNP you guys will learn in the detail way. Getting my point, everyone?
Yes.
Tell me. I hope everyone understand till now what we discussed. Tell me, everyone.